study from California of millions of people has found that taller people are more likely to suffer from chronic disease and die many years earlier than shorter folk. Health has long been linked with height. I'm 6'2", but the belief, backed by lots of historical evidence, is that if I were even taller, that'd be even more impressively virile and healthy. But now this massive study of global mortality statistics has turned the accepted wisdom on its head. Shorter people live significantly longer. That can't be right. Yes, it is. At 5'6", all other things being equal, I'll live roughly 14 years longer than him. What? Yep, 14 years. Blimey, what about me? How long will I live? Because this is how tall I really am. The good news is about 6 years longer than me, but roughly 8 years less than me. So I could do with losing a few inches, as well as from around the waist. Scientists believe that taller people's bodies go through more cell divisions to reach full size, so there's not much left to cope with the wear and tear of ageing. But before shorter people get too smug, other studies show that taller people are usually more wealthy.
You're watching Discovery Science, where we go from the paranormal to space travel and investigate the latest advances in technology, all in the one day.
Take the ultimate trip, a journey through time. Burst into the future, leap into the past. Scientists thought it couldn't be done, but were they wrong? Imagine the thrill of the ultimate adventure, a journey into the future or a tour of the past.
Think about it. You could go back billions of years and see the solar system form. You could see life begin on Earth. You could see the pyramids being built. You could visit the crucifixion.
It used to be considered pure fantasy. But remarkable developments in science are bringing us closer than ever to pushing through the barriers of time, leaping from one century to another. It's something most scientists argued could never be done, but others have clung to the dream and continued searching for ways to somehow, someday, break through the barrier of time.
It's a feedback between science fiction and science reality. Almost anything you can imagine in science fiction, it's starting to come true today.
One scientist claims he's already made music time travel, giving new hope that we too may one day make that journey. Every hour of every day, we push the limits of time and space. Racing the clock to break one record after another. Testing ourselves against the seconds, the milliseconds, the femtoseconds. Time and space are linked to speed. For example, flying rather than driving from Los Angeles to New York cuts traveling time from days to hours. The increase in speed allowing more space to be crossed in less time. These air travelers may not know it, but they're about to take a voyage into the future. The faster they fly, the slower their watches tick compared to clocks on the ground. Even at these speeds, the difference amounts to no more than the tiniest fraction of a second. When they land, they have jumped imperceptibly forward in time. This phenomenon was identified by Albert Einstein more than 80 years ago. His calculation showed that time flows more slowly for someone moving at a high speed than for someone standing still. It's this relative difference in the flow of time that causes all airline passengers to jump fractionally forward into the future. This effect is called time dilation. It sounds truly strange, and the faster you go, the stranger it gets. For example, identical twins, one called Ted and the other named Bob. Bob joins a starship and zooms into space, leaving his brother on Earth. Because he's traveling so fast and clocks on the spaceship are recording time slowly relative to clocks back on Earth, Bob is stretching the age difference between himself and his twin. After a 2-year journey, this would be his calculation of how large that time gap had become.
I'm 2 years older, and my poor brother Ted has aged 140 years. It's as if you hopped in your almost at the speed of light spaceship when Benjamin Franklin was just a young boy. And now you're coming back after aging only 4 years, just barely in time for the turn of the millennium parties.
Solid rocket ignition and liftoff. Liftoff of Columbia on a voyage to the future.
Because spacecraft travel faster than passenger planes, the time dilation effect is greater. For example, astronauts on board the space shuttle orbit the Earth at more than 27,000 kilometers an hour. If they were to stay in space for a full year, on their return home, they would have jumped 3.8 seconds into the future in Earth time. Much faster travel would cause them to jump much further ahead. But if going forward in time is as simple as building faster spacecraft, why aren't we designing them now? The fact is, in order to gain any big jump on time, we need to travel thousands of times faster than even our fastest spacecraft can carry us. If the shuttle could travel 4,000 times quicker, astronauts could leap more than 60,000 years forward in time. NASA already has super-fast rockets on the drawing board, but the most powerful will still only drive us at 40 kilometers a second. Nowhere near fast enough to make a jump into the future. Despite the difficulties we may face in trying to achieve ultra-high speeds, physicist Dr. Jack Safati believes we must take up the challenge.
So let's do it. Let's get ready. The monolith is here. It's all. Let's get ready for the big trip into the 21st century and out into space. Let's make Star Trek real.
To do that, we'll have to break some seemingly insurmountable barriers.
This airplane and this pilot are about to be the first ever to fly faster than the speed of sound in level flight.
50 years ago, American pilot Chuck Yeager became the first person to fly faster than the speed of
In
sound.
level flight will be the really big moment.
Yeager proved that the sound barrier was not a physical limit, merely an imaginary one.
In the Smithsonian Institution.
But beyond the sound barrier is a theoretically unbeatable barrier. The light barrier. If we move faster and closer to the speed of light, we jump further forward in time. But if we could somehow travel faster than the speed of light, then in theory, we could go backwards in time. Using a speeding bullet as an example, imagine traveling equal to its speed. As we accelerate to catch up with the bullet, time dilation would begin to occur. But when we reach the same speed as the bullet itself, it would seem to stop in mid-air, because time is flowing at the same rate for it and for us. If we could eventually overtake the speed of light itself, Then time would flow backwards. The laws of physics say that it isn't possible to travel faster than the speed of light. However, there might be scientific loopholes that would still allow us to travel back in time.
For years we've been told you can't do that. There's no way to do it. Now we're starting to get theoretical models that say, wait a minute, yes, you can do that.
Just imagine what the ultimate time machine might look like. We used to think in terms of cogs and wheels. A mechanism that would spin and flutter through time. But a modern vehicle that carries us away from the present might simply look like this. A room with a chair where the traveller could sit in comfort and isolate the day, the hour, the minute they wish to visit. To achieve the dream of travelling back through time, we're going to need to develop some powerful technologies. Super-fast starships will never be enough. Science has warned us that even the fastest spacecraft still couldn't cross the light barrier. That's because when we gain speed, we gain mass. More mass means an increase in the force of the gravity. At the speed of light, 297,600 kilometers a second, we'd be crushed by gravitational forces before we could ever make it through the light barrier. But one loophole scientists have identified may provide a way around that problem. They're called wormholes. Wormholes are natural pathways that bypass space and time by jumping through them. Long journeys will become split-second hops, the wormholes eliminating the distance and time separating our departure and arrival points.
Go in one end, you come out the other. To an outside observer, it looks like you went faster than the speed of light. You're not torn apart by horrendous gravity fields. It doesn't take forever for you to travel through the wormhole.
It's the concepts behind fictional technologies featured in Star Trek, Deep Space Nine. Starships move through wormholes from one part of the universe to another, all without harming anyone on board, with the deadly gravitational stresses of faster-than-light travel.
We can only go so fast, so far. With the wormhole, it's instant gratification. And we are, after all, a culture that needs instant gratification. So it's like you can get there where you thought you'd never go, to a place you thought you'd never see. Not only can you get there, but you can get there in a heartbeat.